Alright, I admit it, the haters were right. My desk PC is a dangerous fire hazard that's on the verge of melting itself down.
Or, well, not quite, but it is overheating, which is costing me quite a bit of performance, and I'm sure it's not great for the components of the computer either. When I first built this PC, the whole custom PC building world was a completely different landscape. The original drawer PC sipped like 200 to 250 watts of power. A couple of upgrade cycles later, and this current iteration gobbles down up to 600 watts of power. And to make matters worse, I just bought an RTX 4080, which might push that number closer to 700 watts. All of that waste heat has to go somewhere, and this current setup just can't get it out of there fast enough. So today, we are going to do something that I have wanted to do since I was a little kid. We are going to water cool my PC. But first, let me tell you about the sponsor of today's video, Anker Work and their brand new M650 wireless microphone. I'm actually using it to record this right now, and I used it throughout the entire production of this video. It features dual channel wireless recording with integrated voice shield technology that helps to reduce background noise and make sure that you sound as clear as possible. It's got a unique, colorful design with interchangeable faceplates and a variety of mounting solutions. You can clip it on your collar, use the magnetic mounting system to pin it just about anywhere, or do what I do and just toss it in your back pocket with a lav mic strung under your shirt. Their TrueLink wireless technology gives you up to 200 meters of wireless transmission range. You can connect it to your camera, your phone, or just about anything that can record audio. Setup is incredibly easy, just plug and play with one-touch controls and a bright, responsive LCD screen so you can easily see your settings at a glance. My favorite feature of this whole system is their integrated charging case. Not only does it keep the whole system organized, but it also has an internal battery that charges your mics when you're not using them and gives you up to 15 hours of battery life. This is legitimately going to be my new microphone setup for making all of my videos, so if you want to get one, check out the link in the video description, and let's get back to making this water-cooled PC. Alrighty, here we are in the shop. We have a whole bunch of really fun computer parts in here from AlphaCool here, but before we get into that, let's get started on doing just a smidge of woodworking.
Originally, I wanted to reuse the existing drawer, but I quickly realized that rebuilding it would allow me to integrate more features and improve its functionality. So we're essentially starting from scratch here. The first thing I did was build what I like to call the sled. This will be what the computer itself gets mounted to. Then, using my CNC, I cut 2 large openings for twin exhaust fans. These will keep air moving over all the heat generating components that aren't directly cooled with water. After that was done, I also started working on these 2 struts that will support the sled inside my desk. And because they're going to be supporting such high-value components, I used the strongest joinery technique known to man: pocket holes.
Alrighty, so that's done. Now, let's change gears and do something completely different. We're going to take this brand new RTX 4080 and install this water block on it. And the reason we're gonna do that is because the total length of the GPU with the water block on it is gonna dictate exactly where I can place the motherboard on the sled. So we need to figure that out before we can go any further.
Back in the much cleaner environment that is my office, I started disassembling the graphics card. This 100% voids your warranty, but it's going to be worth it for that sweet, sweet performance. Off came the old stock heatsink, and on went the new water block from AlphaCool. This solid slab of chrome-plated copper has a series of channels cut into it that allow water to circulate over all the board's heat-generating components and whisk the heat away much more effectively than air. And thanks to the innovation of dynamic clock speeds, better cooling actually means better performance, so we'll do some benchmarks once everything is done on this project.
And just like that, I think we are done. I don't understand why more people don't do this. I mean, look at how small and slim this is compared to what it used to look like. Like, that's a crazy size difference.
For the next couple hours, I carefully laid out components, took measurements, and planned out the layout of my new computer.
Alrighty, we are back in the shop, and next thing we're gonna do is build some swoops for our drawer.
What's a swoop? Good question. Basically, these are just 2 panels that are going to go at the top and the bottom of the drawer. I just called them swoops because of their, well, swoopy appearance. And while I had the CNC fired up, I also added this recessed area at the bottom of the sled. This allowed the motherboard to sit just a little bit lower because I was bumping right up against my Z-axis limit. This actually ruined a cool feature that I had planned, but we'll talk more about that during the postmortem analysis at the end of the project. As is custom on this channel, I used the motherboard as a template to drill some holes that I then screwed some brass standoffs into. These will keep the motherboard elevated just a little bit and keep it from touching the wood in any way.
So, this guy goes here, a little something like that. This guy goes here, and what these do is give us a little something that we can build off of. And also, they give us a convenient place where we can mount things like power switches and this little USB-C port.
Before we could even worry about features like that though, first I had to cut a platform for the reservoir. This simple piece of plywood is actually going to serve double duty. Not only will it support the component responsible for holding excess coolant and circulating it through the system, but it will also be a panel that covers the backside of the motherboard where a lot of unsightly cables congregate. With all the panels cut, it was time to properly screw together the sled. If you're finding all of these raw plywood edges offensive, don't worry, those will get taken care of, but first, we gotta play with some computer parts.
All right, so there's still a few more pieces left to build for the sled, but let's see how this thing fits together because I won't be able to make those next pieces until I figure out where everything goes exactly. So this is the motherboard. Next thing, GPU. The pump and reservoir. It's gonna go right there. And last but not least, PSU. That's gonna go right there. So now, let's figure out exactly where this reservoir pump unit is going to go.
Obviously, AlphaCool ships their reservoirs with mounting brackets, but they're made for more traditional PC cases. So that meant that I had to modify mine. First, I bent one of the tabs to a 90-degree angle, and then, using a cutoff wheel, I zipped off the other mounting point as I wouldn't be needing it anymore. And what I was left with was two nice compact little L brackets. I screwed those onto the piece of plywood that I made a few minutes ago, and then I was able to easily mount the reservoir to the sled. The Intel 13900K at the core of my computer has a serious design flaw. The factory mounting system is so strong that it actually bends the CPU. So I stripped that out and replaced it with this contact frame that holds the CPU in place without bending it. This will allow my 13900K to make much better contact with the AlphaCool XPX Aurora Pro, which is another seriously heavy-duty piece of nickel-plated copper, perfect for taming this power-hungry 24-core beast. I screwed it down, and then I screwed fittings onto each of my blocks and the reservoir. These fittings connect the tubes that will link all of my components together. And while we're on the subject of tubes, let's talk about the different types.
Now basically, there are two ways to do this. You can do it with soft line tubing, which is the easy way, and then there's hard line tubing, which is the hard way. Can you guess which of the two I chose?
We do it, and we do it hard. I'm ready to get hard.
Yeah. Let's talk about the process. So hardline tubing, as the name implies, is hard and rigid. So in order to bend it and get it to connect our various fittings, we're actually gonna have to heat it up first.
But don't just jump right into heating it up. First, you want to insert a mandrel. This slippery silicone snake helps to keep the interior shape of your tubes as you bend them. Another important thing to note is that you don't want to overheat the tubes. If they get too hot, they can discolor, bubble, and in the case of my frosted tubes, lose their texture. Just be patient, spread the heat over a fairly large area, rotate the tube continuously, and eventually you'll find a penis joke in there somewhere. Or, no, sorry, the tube will get soft and then you can start to bend it.
So now we can bring our tube over here and we can pop it in there. And we can see that, well, we got the 90 right, it's obviously too long. So we're trying to connect this fitting to this one, so we just have to now trim it to fit. I wonder if I'm the first person to cut hardline water tubing with a Japanese pull saw.
It's true, this method is going to waste a little bit more material, but it's way easier than trying to figure out the total length of your tubes and then doing all the bending afterwards.
Whoop. And now, before we do any test fit, we want to give this a quick deburr with the aptly named deburr tool. After cutting the tube, they can often have rough edges, and you don't want to jam one of those into the fitting because it might then cut the O-ring and create an opportunity for water to leak out of your system. So this just puts a little chamfer on the edges of the tubes and makes it slide in there nice and easy. And now we test fit. So this is one of those things where you kind of just gotta force it in there. So Yeah, that's actually not bad for a first attempt. So now we have to do here to here, which is going to be a little bit more complicated.
This second section of tube was way harder than the first one because I had two 90-degree bends in it going in different directions. That meant that I had to measure the offset between the two fittings and bend the tube to match. To be honest, it took me more than a couple attempts to get this one right, but thanks to the miracle of movie magic, it looks like I did it in just one. After that, I had one more easy bend to do, and then it was time for a little bit of problem solving.
All right, so at this point, we've hit a little bit of a snag. You see, at this point, somewhere right about here, we need to transition from hardline tubing to softline tubing, because this drawer still needs to be able to move, and well, obviously these hardline tubes aren't very flexible. In order to do that, we need to use this monstrosity of a fitting right here. This is actually a quick disconnect so that we can easily disconnect the rear radiator, but it's really heavy and I don't want to just have it hanging on these lines. So we need to build a little bulkhead here in order to support this thing. So let's head over to the CNC.
My design here couldn't be simpler. I'd make two pieces of walnut that fit together like a puzzle piece, and then I'd sandwich a thin sheet of copper between them. The copper has two advantages. One, it won't corrode my brass fittings, and two, it just looks really cool. Plus, I actually needed these sheets of copper for my next project, but I'll tease that at the end of the video. For now, let me show you how it all goes together.
So now we have our three main pieces. This is the main little bulkhead. We put the copper sheet in there like so, and then this filler guy slides in there like so in order to fill it out. Let's combine these three pieces into one piece.
And in order to do that, it wasn't as hard as you would think. All it took was a little bit of wood glue, plus a few trips through the drum sander. The last step was drilling two holes for the fittings, which I started to do on the drill press, but it got a little sketchy towards the end when the drill bits got a little bit bigger, so instead I decided to finish things off manually with a file.
Hey, look at this, pretty cool, right? I'm pretty happy with how that turned out. So let's see if it works. That goes in there like so. I believe we now have a bulkhead.
And in order to figure out the exact location of said bulkhead, I just connected it to the hardline tubes, clamped it in place, and then screwed it from the outside of the sled.
Alrighty, now that we're done with the bulkhead, let's talk about where that bulkhead is going to send the water. Once it's all heated up, it's gonna need somewhere to cool, and that's why I got this, the Nexos XT45. This is probably better suited for a car, but this is a 1080 millimeter rad. And you call it a 1080 millimeter rad because it has space for not one, not two, not 9, but actually 18 individual fans. All right, let's get this thing set up and then I'll show you how I plan on mounting it.
Two 90-degree softline fittings will allow water to flow in one side of the radiator and then out the other side. Hopefully much cooler at that point. This third fitting, located at the lowest point of the whole setup, is actually a drain port that will allow me to empty out the loop in case I ever need to service anything. Then it was time to install all the fans. Now, because this radiator has so much surface area, I opted to run a rather pedestrian 9 fans. This will limit the total thickness of the radiator, plus it'll mean half as many wires to manage later.
All right, that is some serious cooling potential. I mean, yes, it's a mess of wires right now, but we'll clean that up later. But before we do that, I think what we need to do is figure out how we're gonna mount this radiator to this piece of 1/4-inch plywood, which is going to be the back of the cabinet. So, a little something like that.
Standard disclaimer, obviously you do not need a CNC to cut a hole like this, but if you got one, you might as well use it. And speaking of getting tools, I'll provide links in the video description to all the tools I used, as well as some cheaper alternatives, and key products like all of these water cooling parts.
So would you look at that? The radiator is now mounted to this panel, the panel gets mounted to the back of the desk, and this thing should be basically good to go at this point. So now the next thing we have to do is something that I've been putting off doing for a while. We had to sand and finish all the woodworking pieces.
Nobody likes raw plywood edges, so the first thing I did was install a little bit of edge banding. I opted to use the heat activated adhesive type. Basically, you just cut it to length, use an iron to heat it up, and then press it down with a hardwood block. Once it's cool to the touch, you can use a knife or even a more specialized tool to trim off the excess. a little bit of sanding, 2 coats of my favorite polyurethane finish, and what you'll end up with is a reasonable facsimile of genuine hardwood that only the most pretentious of woodworkers will recognize as anything less than the real deal.
Now that the finish is dried, there's nothing left to do but put this all back together in 3, 2, 1. Boom. There we go. It is all assembled, and now we are ready to take it home, fill it up with water, see if it fits in the drawer, and I'm sure do a whole bunch of other little troubleshooty jobs, but yeah, look at that. All right, let's not waste any time. Let's take this bad boy home and try and get him set up. So step number 1 is just going to move this desk out off the wall a little bit so I can get in there and work. I do love this desk, but man, is it ever heavy. It must weigh, I don't know, 300 pounds. Old back panel comes out nice and easy. I guess I should have said something funny there, but I got nothing. Now, we are actually going to reuse these slides because they are good slides. However, using them in this configuration hasn't really been optimal. So what we're going to do is change their orientation.
But first, I had to install those vertical struts I made earlier. In order to make sure that the drawer functions smoothly, I used spacer blocks to set the struts exactly where I wanted them. And then it was time for a quick test fit.
So this is a very important test. We have to see if there's enough clearance between the slides and the edge of the cabinet in order for the computer to actually fit in there. But no, I think we're good. It just fits, which is what I was aiming for. There, yay, it fits, it fits. So in order to center the drawer inside the cabinet, I've actually just used these credit cards as a shim to kind of evenly space out the gap between the top and the bottom. And now we're just gonna pull it out and screw it to the drawer slides, 1 screw at a time.
Next came the rear panel. With the radiator already attached, all I had to do was screw it to the back of the cabinet and it was good to go. I connected the soft line tubing to the radiator and then the quick disconnect fittings to the PC side of the equation. At that point, I was ready to attempt to fill the loop. It's always a good idea to spread some paper towel around so you can easily locate any leaks, and good thing I did because boy did I ever have some. The first one was an easy fix, just a loose plug on the reservoir. But the second one, well, that one was a lot bigger.
No. Wait. Wait.
And this is why you always leak test your system without any power on. Anyways, basically I had pinched an O-ring inside of the reservoir, so I had to drain everything, pull out the drawer, and rebuild the reservoir. After that, I filled the system most of the way, and then hit another roadblock.
The loop is basically full at this point, but there's still a ton of air in the reservoir that I can't really get out of there. The only way to get at it is to open up the fill port at the top of it and get it out that way, add a little bit of fluid into the top of the fill port.
The problem is, there is no way to access the top of the reservoir, a design oversight on my part that I rectified by simply drilling a hole directly above it. Unfortunately, this is kind of ugly, but don't worry, I'm gonna fix it with a very cool new tool that I just got a little later in the video. But first, I finished filling the loop by squirting in 12 milliliters of coolant at a time. And then I had a very ceremonial job to do. Like the passing of the torch from one generation to the next, I removed the drawer front from my old desk PC and attached it to this new one. I used double-sided tape and more credit cards to precisely locate the drawer front. Who would have thought that being in so much debt would actually be useful? A couple of screws permanently fixed the drawer front in place, and then I had many hours of zip tying, cable managing, and looming wires together to make the whole setup look halfway organized.
Well, now we get to boot it up. Okay. Here we go. 3, 2, 1. Water's going. I see movement. You know, I don't mind a little bit of lighting in the case. I think it makes it look kind of cool, but I don't understand why people do these crazy rainbow patterns. Oh boy, we're booted. Look at this. We got 36 degrees on the CPU right now. That's a good sign. I mean, not under any load just yet, but I like that number. That's a good sign. Alrighty, so it's a couple of days later. I've got the machine more or less dialed in, and I've also made a couple of key improvements. First, I 3D printed this grommet to cover the ugly hole here. I also 3D printed this cover to cover all the wires at the bottom of the computer and just clean things up a little bit. And then this one's a little hard to see, but I actually ordered a temperature probe that screws into the top of the reservoir, which monitors the coolant temperature and allows me to more effectively control the fans of the computer. And speaking of fans, well, They barely even spin. That is one of the key advantages of water cooling your computer. It's dead silent in anything but the most strenuous activities. And even then, it's barely even audible. For instance, I'm actually rendering a video right now, and yeah, no, the fans are not spinning. The ones at the back are spinning just a little bit, and I can't even hear the pump. And while we're on the subject of improvements, let's talk about performance. I benchmarked this computer at the start of the project, and I was getting about 36,000 points in Cinebench. I'm now clocking in at over 40,000 points. So we're talking about a 10% uplift on what is already the fastest consumer-grade CPU that Intel has to offer. 3D performance, on the other hand, is absolutely off the charts, almost double in a lot of scenarios. But that is to be expected given that I did upgrade the GPU. This new GPU is locked at 45 to 47 degrees Celsius, which allows the GPU to hit its max turbo and also allows for a substantial overclock over and above even that. So we're running cooler, we're running quieter, we've picked up some additional performance, and in addition to those benefits, I also happen to think that this new computer looks way better than the old one. We went from something that looks like this to something that looks like this. So that's it for the good. Now let's talk about the bad in the postmortem analysis. First up, we have cable management. This setup could honestly be a little bit better, and I did have a plan to hide all of the cables behind the motherboard, but I actually ran out of Z-axis height because the GPU would hit the cabinet if it were any higher. So I was thinking one potential solution might be to bring the wires through to the back side of the drawer and then just zip tie them down really tight. Similarly, I do feel like my 3D printed shroud could be a little bit nicer. And truth be told, as I get better at 3D modeling and 3D printing, that's probably the route that I'm gonna go to manage all these wires. I'll just print custom shrouds to cover all the stuff that I don't like. GPU sag is another thing I'd like to take care of with the 3D printer. As you can see, it sags about 1 millimeter or 2, so what I'd like to do is print a strut that goes from here down to here, hides this wire, and then obviously lifts the GPU a little bit. And then finally, this last one's a little tricky to even show on camera, but I would like to add a drag chain inside the cabinet in order to help manage the wires and the hoses. As you can see, it's actually not bad, but I do worry about them long term. Opening the drawer hundreds of times might become an issue. In my next video, I'm going to mod this phone that I bought off of Craigslist for a couple $100 into the ultimate mobile retro gaming machine. So get subscribed so you don't miss that, and I will see you then. Peace.